Good day, and welcome to an episode of my reviewer series for civil engineering topics focusing on engineering mechanics problems. In this episode, a load of 6 kilonewtons is supported as shown in the figure, and the weight of the pulley is 2 kilonewtons. Upon solving, we are to neglect the weight of the bars, and with that, we are to determine the following: the reaction at B, reaction at C, and the angle of reaction C with the horizontal. So to start this, let us make ourselves familiar muna with the system of its force equilibrium. So si 6 kilonewton weight is connected to a cord that is supported by a wheel, thus making up the pulley system of this figure. Tapos yung wheel sa figure is connected to a bar that is hinged at B. And in order to hold the position of this bar, which we will call bar BCD, meron tayong isa pang member in the shape of a right angle na connected sa bar BCD dun sa point C, which is by pin. Tapos hinge naman at the other end here at point A. With that, start na natin i-perform yung solution for the first unknown. For the reaction at D, pwede natin to i-analyze by free body diagram since kung mapapansin nyo, yung wheel natin is pin-connected sa point T, and yung external forces caused by the weight of the wheel and the cable is just transmitted at that point. So separating a section considering joint D lang muna, to determine the reaction, perform lang tayo ng summation of forces along horizontal and along vertical. For the resultant along horizontal, alamin lang natin yung tension ng cable. Given on the other end of the cable is may binubuhat siyang 6 kilonewton load, and as we all know, iisa lang naman yung tension na ma-experience ng cable sa kabuuan ng length nito, we can all agree that the tension of this side of the cable is also 6 kilonewtons. And for the resultant along vertical naman, consider lang natin ulit yung weight ng wheel since indicated to sa given problem. With that, 8 kilonewton yung total downward force natin. Therefore, in getting the resultant force, which would also be the equivalent reaction at P, apply lang tayo ng Pythagorean theorem, then makukuha na natin yung value na 10 kilonewtons. For the next unknown naman, in order to solve for this, need muna natin i-separate yung bar BCD and right angle bar AC into different force equilibrium systems, since yung na-experience sa hinge at C is internal force. And to start our solution, observe muna natin yung bar BCD and try natin i-apply lahat ng possible force equations. So performing summation of forces along y equal to 0, ang mako-consider nating forces is yung vertical forces at B, C, and D. And take note, nakuha na natin yung value ng D kanina, which considers the weight of the wheel and yung weight ng block transmitted dun sa tension ng cable na nakakabit sa wheel. Therefore, using the solved vertical value of D kanina and rewriting our equation, we will get By plus Cy equal to 8. And since meron tayong 2 unknowns and di pa natin makukuha yung sa vertical component ng C, try muna natin yung ibang equations. For the summation of forces naman along horizontal, similar scenario lang siya sa summation of vertical kasi magiging unknown values mo is yung horizontal components ng B at C. At yung D lang yung meron kang value which is 6 kilonewtons. As for the last possible equation for this system, if we are to take a moment about the hinge at B, the unknown values at B would not be necessary anymore since yung sa C at D lang need natin i-consider. And since along the axis of B yung iti-take nating movement, vertical components lang yung need para dito. So moment of Cy is equal to Cy times yung distance niya from B, which is 2 plus 2 plus 0.5 equal to 4.5 meters. Then para sa sign convention, gawin natin tong counterclockwise positive. Therefore, taking the moment for dy naman, which is equal to 8 kilonewton, we just have to multiply this by its distance of 7 meters from point B. Equating the equation to 0, we can solve for the value of Cy, which is equal to 12.444 kilonewtons. Looking at how we're not able to determine the value of Cx in this system, try natin yun kuhanin from the separated system of member AC naman. And kung mapapansin nyo guys, yung reaction at C is positioned towards opposite directions compared dun sa ginawa nating analysis kanina. And the reason for that is, syempre, given na when combined yung members BCD and yung AC is dapat ma-maintain yung equilibrium, dapat opposing forces yung ma-generate from the two systems. So moving forward, if we are to apply summation of forces along Y, dalawang force component pa yung magiging unknown, which is yung sa vertical reaction at A and sa C. Same scenario din to with the summation of horizontal forces. So with that, we will observe na makukuha lang natin ulit yung isang force component at C by performing moment equation. So taking moment about A, considering counterclockwise as our positive direction, we will end up with this equation. And simplifying this further, we will get the horizontal reaction at C, which is equal to 26.917 kilonewtons. Now that we have our horizontal and vertical components for the reaction at C, perform na lang tayo ng Pythagorean theorem para makuha yung resultant force, which is 29.654 kilonewtons. So kung mapapansin nyo, madali lang talaga i-solve tong problem na to if kabisado na talaga yung mga concepts ng force equilibrium and structures. Like if 2D yung ina-analyze na figure, meron tayong 3 force equations na pwedeng gamitin, which is yung summation of forces along vertical, summation of forces along horizontal, and yung summation of moments. And also like, if kung meron tayong hinge support, dapat laging 2 force components ang i-consider, which is yung X and Y components. O kaya naman yung isa pang ginawa natin kanina, na separation of members, para makabuo ng dalawang force system. Doon lang naman possibly pwedeng malito yung iba if di pa talaga familiarized sa ganitong analysis ng mga structures. So, ang tip lang talaga for this is, as much as possible, try to perform more practice problems para in the long run, pag sinubukan nyo i-observe yung figure, madali na mag-make sense sa inyo kung paano mag-apply yung mga internal at external forces na magaganap sa system na isa-solve nyo. Pero going back, meron pa nga pala tayong isang unknown na need natin ma-solve, which is yung angle ng reaction at C with the horizontal axis. Basically, trigonometry na lang naman yan. And para di nyo na masyado isipin kung paano i-perform yung concept na yun, memorize nyo na lang yung formula na angle theta equal to arctangent of y component over x component. That is if yung hinahanap yung angle is with the horizontal. Kung with vertical naman, pagpalitin nyo lang yung position ng y component at x component sa formula. Or pwede rin naman, gamitin nyo lang yung same formula kanina, tapos minus nyo na lang yung value sa 90 degrees. Yun lang din naman kasi yung angle difference from horizontal to vertical axis. So performing the solution, arctangent theta of 12.444 over 26.917 is equal to angle 24.813 degrees. And that's it. For further questions, don't hesitate to leave any comments below. And with that, this situation is finally solved.